We were instructed to open our canvas and watch the demonstration video given to give us a reference upon doing the activity. As stated in the video, we used the PET simulator in doing the activity. The link for PET was given, and upon clicking it, we chose the microscale to be used in the activity.
For this experiment, we don't need that much material. All we need is the PET simulator, which is already provided. All we have to do is first click the link and it will automatically open and lead you to the PET simulator. And once opened, we will see the macro scale and we must click it. And after that, there will be two figures shown which represent the charges. The blue one is a negative charge while the red one is positive. And you can drag these figures to determine the particular charge that you want. Then with our first set of data, we will have an increasing value of charge, but we must keep the distance between them the same. Also, we must set the marker on 0 so that we can identify how far is our second charge from the first one. After that, we are given the chance to decide what distance we will be using, and this is going to be shown on the table later. After that, we will record the force, which is either attraction or repulsion, and we can determine it by looking through the arrows. And the first set will have an increasing value of charge from trial 1 up to trial 5. In the second data, we are given the chance again to decide what charge are we going to use, but this time we must vary the distance by basing on the ruler. And with that, we must simply record the value which is already provided once you adjusted the figure shown, and that would be all for the data gathered. It will be explained later on the video.
Using PET simulator for table A, the distance between the charges is held constant. For trial 1, amount of charges is equals to -2 for Q1 and +2 for Q2. The distance between the charges is equals to 0.05 meter, and forces between the charges in Newton is equals to 14.380 Newton. And this is how we get the values in the table. For trial 2, the amount of charges is equals to -4 for Q1 and +4 for Q2. Distance between the charges equals to 0.05 meter, and forces between the charges in Newton is equals to 57.520 Newton. For trial 3, the amount of charges for Q1 is equals to -6 and Q2 is equals to +6. Distance between the charges is equals to 0.05 meter, and forces between the charges is equals to 129.421 Newton. This is how we get the value for trial 3. For trial 4, the amount of charges for Q1 is equals to -8 and Q2 is equals to +8. The distance between the charges in meter is equals to 0.05 meter, and forces between the charges is equals to 230.081 Newton. And this is how we get the values for trial 4. For trial 5, the amount of charges in Q1 is equals to -10 and Q2 is equals to +10. Distance between the charges is equals to 0.05 meter, and the forces between the charges is equals to 359.502 Newton. This is how we get the values for trial 5.
For the table B, the amount of the charges are held constant. The charges that we are going to use for this table are positive 1 for the charge 1 and positive 5 for the charge 2. For the trial 1, these are our charges. The distance between the charges is 10 centimeters. Converted it in 2 meter, we have 0.1 meter. And for the forces between the charges, we have 4.494 Newton. For the trial 2, we still have the same charges. The distance between the charges is 8 centimeters. Converted it in 2 meter, we have 0.08 meter. The forces between the charges is 7.22 Newton. For the trial 3, we still have the same charges. The distance between the charges is 6 centimeters. Converted it in 2 meter, we have 0.06 meter. The forces between the charges is 12.483 Newton. For the trial 4, we still have the same charges. The distance between the charges is 4 centimeters. Converted it in 2 meter, we have 0.04 meter. And for the forces between the charges is 28.86 Newton. For the trial 5, or the last trial, the charges is still the same. The distance between the charges is 2 centimeters. Converted it in 2 meter, we have 0.02 meter. And the forces between the charges is 112.344 Newton.
The interaction between electrical objects is defined by Coulomb's law. It quantifies the amount of electrostatic force exerted on each other by two charged objects, which induces an interaction between them or repulsion. Either two positive or two negative charges will repel one another, like charges or having the same symbol. In comparison to charges or distinct sign of positive and one negative charges, we use positive charges resulting in a positive power. In this laboratory experiment, it was started in the law of the Coulombs that the force exerted on each other by two charged objects was proportional to the products of the magnitude of the charges and inversely proportional to the square of the distance between them. In our observation, while doing the experiment, we found in our first collection of data that the force between the charges and the charges of Q1 and Q2 were directly connected when the distance between the charges was kept constant and the sum of the charges varied in an increasing manner. In our second collection of results, we found that the forces between the charges decreased when the charges of Q1 and Q2 were maintained constant and the distance varied and arranged in an increasing way. This is because the force is inversely correlated between the changes and the distance. We also note that when we set the distance of the charged object to each other, the lower forces between the charges. The greater the force between them, the closer the charged object is to each other.
The Q1 and Q2 were set in an increasing manner in this laboratory experiment, and the distance between the charges was kept constant because the force magnitude was directly proportional to the product of the two charges and inversely proportional to the square of the distance between the charges. The resulting force would be greater than the preceding value if the charges increased while retaining the same distance. Although Q1 and Q2 remained the same, and the gap varied more and more, the force value decreased. We have also observed that the closer the distance between the charges, the greater the force value, and the further the charged object is to each other, the lower the force.
We concluded that the theory governing the electrostatic law of Coulomb claimed that the electrostatic force between the two charges is directly proportional to the magnitude of the two charged objects and inversely related to the square of the distance between each charged object. Electrical forces are sensitive to distance, we have also inferred. The force of attraction or repulsion between objects decreases by increasing the separation distance between objects. In addition, reducing the distance between points charged, the attraction or repulsion force between them increases. The correlation between the forces generated on each other by the charged objects when positioned at a certain point of distance was established by Coulomb's law.